This is part 4 of section 3.1. If Carmen has $9,000 to invest and she needs $20,000 at the end of 8 years, if the interest is compounded monthly, find the rate R needed to make that happen. Okay, so let's organize what we have here. She has $9,000 to invest, so my principal is going to be $9,000. She needs $20,000, so that's going to be your future value. So that's A. At the end of 8 years, so that means your T value is 8. If the interest is compounded monthly, so that means your N value is going to be 12. And we're looking for R. So as we solve this problem, we're going to get R as a decimal. They're going to want R as a percentage at the end. So we are going to need to do that last conversion there. It shouldn't be difficult. Okay, so I'm going to take this and plug it into the formula. The formula for compound interest is A equals P times 1 plus R over N raised to the N T. Okay, so this is 20,000 equal to 9,000 times 1 plus R over 12 to the 96th power. Okay, so I just need to get R by itself. So the first thing I'm going to do is I'm going to divide both sides here by 9,000. So you get 20 over 9 equals 1 plus R over 12 to the 96th power. Okay, now we're going to get some ugly numbers. You want to make sure that you don't write down any decimal approximations until the end. So things might look ugly until we've done all of the algebra. Now, to get rid of a power here, what you technically do is you're going to take the 96th root of both sides, but that's the same thing as raising both sides to the 1 over 96th power. So this is the same thing as 20 over 9 to the 1 over 96, and that's going to equal 1 plus R over 12. Okay, now subtract 1 from both sides, and I will have 20 over 9 to the 1 over 96th power minus 1 is equal to R over 12. And now to get R by itself, we just need to multiply both sides by 12. So I have 12 times 20 over 9 to the 1 over 96th power minus 1 is equal to R. Now that we've done all of the algebra, we need to plug this into our calculators and get an approximation. R is approximately equal to 0.100229729. And they've asked for the rate as a percentage raised with 3 decimal points. So if I multiply this by 100, I get 10 point, and then I'll have 3 decimal places after, so I need to round here, which means that becomes a 3. So 0.23%. So that's the interest rate she needs to get that happen, to make that happen. Okay, now we've seen that you earn more money the more times your investment is compounded in a year. But is there a limit to that? Okay, so compounded daily is better than weekly, but hourly would be better than daily, and minutely would be better than hourly. Every second would be better, nanosecond, millionth of, how far down does it go? There is a limit to that. And this will become more and more apparent as you go into calculus. But the larger the value of n, we'll find that things start to converge. I mean, they'll get closer and closer and closer to the same number. And that number is called the Euler number, and it is pronounced Euler. It's named after Leonhard Euler. And we call this special constant E. Now, E is an irrational number. It's called a transcendental as well. So in that respect, it is like the value of pi. E by itself is, for the first 15 places, looks like this. An irrational number is a decimal that never ends and never repeats. So even though it starts to look like it repeats right in here, 1828, and so on, it actually doesn't. It starts to mess up after that bit. Okay? Now, if you want just the value of E on your calculator, on a calculator like this, you're going to have e to the x power right here, and you can hit this button several times to just get e. If you are using a graphing calculator, and I don't have batteries for this one at the moment, your e button is right here, and if you want simply e, you're going to have to figure e to the first power. Okay? And then we can use this to talk about continuously compound interest. So this is what if we are doing it more often than even every nanosecond? What is the absolute limit for the number of times we can possibly compound in a year? And it gets close to this formula. T is still in years, P is still principal, A is still the future value, R is still the interest rate as a decimal, and T is still the number of years. Okay, so let's do an example problem. Find the amount, the future value, when you have a principal of $9,000 and it is invested at 6% annual rate, and it's compounded continuously. If you don't see this word, you're not going to be using the formula we just had. For 8 years and 3 months. Okay, so my principal is 9,000. My rate as a decimal is 0.06. Continuously, so I'm using A equals PRT, but I need to do this time in years. Well, what is 3 months? That is 3 over 12, which is 1/4, which is 0.25. So my time in years is 8.25 years. Okay, now let's use our formula. A is equal to P times E to the RT. Okay, and then you plug this into your calculator and you will get approximately 14,000. Oh, well, let's see if I can write this correctly. $14,764.48.